Your disappearing friend?
Yeah.
You have a disappearing friend?
Oh yeah, where is she? She's
Alright.
She's
I got
very.
it.
She's
Okay. Alright, guys, everybody serious. Now we have only 57 minutes. And we'll see what all we can learn with the time we are left with. So we have. You must be feeling cold out there, right? You're good? I will close the door. I'm just waiting for one child to come. So we have Saurya, Simon, Sunil, Dikshita, Suhina, Arab, Advik, Sami, Nihan. Hello, and yeah. And one last time request before I get started. Make sure that if you guys are comfortable, keep your videos on so that I can bother you guys a little bit more. Yeah. Okay. So what are we going to learn today? So Moira and Aryahi, you guys also forget about you both being friends for next 1 hour. Because if the kids remain friends, it becomes difficult for me. Okay? Alright. Give me 30 seconds. I have one more friend for you guys.
Hello. Nice meeting you.
Find a place for it. Today, the class full of girls.
Yeah.
So what? You can be my guest.
Yeah, I'll sit here for 5-6 minutes.
Okay.
And then
I'll have to close the door
Okay, sure.
so that the heaters
Sure.
can do its job.
Okay. And we didn't know what to bring, so we just got a notebook and pen.
I just did the case. Okay. Close the door. So, do you guys remember or has anybody's parents told you what exactly we are going to cover in the class today? No? Okay. So, your name, beta?
Iksha.
Ifsha, yes. Yes, Gayatri. You remember what the topic is?
So can you hear me?
I'm sorry, beta?
Can you hear me?
Yes, I can.
Okay, so it's we're typing. It says that we're gonna revisit exponents and learn how to do them with flashcards.
Exactly. So, Ifsha, this is your first class. So, certain thing that you would want to be aware of, that when we are in the class, there is no need to worry about taking notes. Everything that I am doing or whatever is happening on the board is getting recorded through this iPad. And this will be a video for each one of you to use later on to revise, to make your own notes with some peace of mind. When in the class, your only goal would be to follow the concepts, argue with me, debate, get your doubts clarified. That's it. Okay? And then we'll do some problems related to the concept that we learned. So, ask your doubts. You see all the kids here? None of them you were knowing before. So, if you give an answer that is not right, doesn't really matter. Yeah? So, that fearless learning is what I'm trying to ensure here in the class. Nobody has to be afraid of giving the answer and then thinking, okay, will it be right? What will people think? Nobody thinks anything about us. We are all normal people. Okay? Don't worry about it. Okay? Yeah? Ifsha, okay, beta? Okay. Alright, so as Gayatri mentioned, that we are going to talk about negative exponents and rational exponents. Is there anyone in the class who doesn't remember or recall what is exponent? And it's okay. Just be honest. And I don't have the option of saying no, I don't remember, but how about you guys? Nobody remembers exponent? My God. My job is at risk now.
You said raise your hand if you don't know.
No, just the exponent. We'll pick up the onions one by one. What is exponent?
Oh, it's a number above a number.
Number sitting on the head of another number. Yeah? Okay, Gayatri, is that your understanding too? Right.
Oh, I have to raise my hand.
Okay. So now, if you have heard this term exponent before? Okay. So, like in the lamest way, if I have to describe like a child, say okay, a number sitting on the head of another number. This is exponent. Yeah. Now we have learned some certain rules or concepts around it. Let me first give you guys different flavors of it. This is regular exponent. If I put another number, let's say 4 to the power 1 by 2, any fraction is called a rational number. So when you have an exponent where the power is in the form of a rational number, that's called rational exponent. Yeah. If I have an exponent to the power minus 2, this is also an exponent, this is exponent, this is exponent. Here it's a natural number, here it's a fraction, a rational number. Here it's a negative power. So this is called negative exponent, this is rational exponent, and this is exponent. Clear demarcation between the three types. Yeah. So I'm 49, okay? Even if I turn 65, the definition of this will not change. Yeah? So if after 20 days I forget what is exponent, if I ask you guys what is exponent, you will give me the same definition, okay? Never ever wipe out this concept from your mind. Yeah? Everybody okay? So I saw some kid joining in between. Is everybody on the screen okay? Sandrine, Celine, I think it was Milana who joined just now. Yeah? So Hina, Sani, everybody okay, right? Now, let me take you guys back in history and then we'll relate that with the present. So there are 3 rules of exponent that we learned in the past. And Ifsha, I will call out your name multiple times, not because I'm trying to put you on the spot, but just to make sure that your understanding of these concepts are same, or if there's any gap, we'll bridge that. Okay? So there are 3 rules of exponents that says x to the power a times x to the power b equals x to the power a plus b. This is the first rule, rule of multiplication. When you have the 2 exponents with the same base, the power gets added. If you have 2 exponents, with the same base, this is the base and this is the power, which is called exponent. Yeah. If you have 2 exponents with the same base, and when you're trying to divide one by another one, the power gets subtracted. And the third rule of exponent says, if you have an exponent inside the parenthesis and then you have an exponent on the top of that, the power gets multiplied. Does everybody recall all that we have done in the previous classes with these rules? And it's okay to say no. No? Tell me, you guys don't have to. Ifsha, have you come across these rules in the past? Not yet. Okay, that's good. That's an opportunity for me, right? When you guys say no for anything, that makes me super happy, not sad, because I can teach that. Yeah. So that's why I say this class is meant for fearless learning. Learn something. If you forgot something, it's okay. We'll learn it again. And we all keep forgetting things. Okay. I don't remember how many times I forgot the same concept that my dad taught me. So many times. It's normal, very natural. So never feel bad about it. Sami, Gayatri, do you guys remember better?
Yes, sir.
Okay. So I will take initial 5 minutes or maybe 7 minutes to decode these rules in the simplest possible way, and then we'll reuse those rules for coming back to rational exponents as well as negative exponents. Maya, do you remember? Yeah? Arya, you remember this one? Sandri, okay? Miss Santa, okay? Okay, so here's the thing. If I have, let's say 2 to the power 3 into 2 to the power 2, I'm trying to multiply them. If I have anything to the power 2, what does it mean? That means 2 into 2 into 2, correct? So I can write this in a simpler way, 2 into 2 into 2, correct? This one. Similarly, if I am talking about 2 to the power 2, that I can write as 2 into 2. Yeah? So how many 2's we have? 5 2's. If I want to rewrite the same thing in the exponent form again, it will become 2 to the power 1, 2, 3, 4, 5. What actually happened? These and these got added. Yeah? That is why this rule says if you have two exponents with the same base and you are multiplying them, the power gets added. That's exactly what we saw. We have this exponent both with the same base, the power got added. Saran, Salim, Dikshita, okay with this? See, many of you must be thinking that this is something that we have learned 4 times and why this old man is wasting time teaching it one more time. Remember this concept will come back to you guys when we come to these, okay? That's why I'm re-emphasizing this. So whether you're learning it for the first time or the 25th time, unless you're able to use it for your benefit, it is not going to help, okay? So even if you are getting bored right now, enjoy that boredom for next 5 minutes. Okay, now this was the first rule. Second rule, and Ifsha, you will see your teacher playing with math. I'll show you what game I'm talking about right now. This game is this. If I have 5 to the power 6, let's say, I'm trying to divide that by 5 to the power 2. Okay? 5 to the power 6 is nothing but 5 into 5 into 5 into 5 into 5 into 5, 6 times, correct? 5 to the power 2 is nothing but 5 into 5, 2 times, correct? Now, fun time. I call it tic-tac-toe. When you are doing multiplication, above below, yeah? This one and this one tic-tac-toe, done. This one and this one tic-tac-toe, done. What we are left with? 1, 2, 3, 4 of 5. Which I can rewrite in the exponent form as this. If you look at it carefully, you have this exponent and this exponent both with the same base, different powers. You converted that to an exponent with the same base with the power of the denominator being subtracted from the numerator. That is our second rule of exponent. X to the power a divided by x to the power b, both are same base. You are subtracting the power. Yeah, that's what we saw here. Everybody okay? Nobody is feeling sleepy, right? Somebody who has learned it before? Okay. Keep drinking water or whatever it takes for you to keep yourself awake. This will become a nightmare in 5 minutes if you are sleeping. Okay. Let's come to the third rule, which is x to the power a in parentheses to the power b equals x to the power a times b. And we'll see that happen. Let's say if I have 2 to the power 3 in parentheses to the power 2. Okay? What does it mean to us? It means whatever I had in the parentheses is repeated 2 times. That means 2 to the power 3 is repeated 2 times. Correct? I mean, if I write it like this, what does it mean? X into x into x, correct? 3 times, that's it. So whatever we have here is getting repeated as many times. Yeah? Now if you look at it carefully, you have 2 exponents with the same base getting multiplied. You apply the same rule here. It became 2 to the power 3 plus 3, 6. Or you can write this as 2 to the power 3 into 2. Nobody is friend in the class, only teacher and student. Okay? Everybody with me? Okay. Alright. So, and why I'm saying so is if I have power 3, you will see the same thing coming one more time. 3 plus 3 plus 3 will become 9. Okay? Which is as good as 3 into 3. So this is my third rule of exponent. Yeah? Now, all the kids dozing off should wake up because the ride starts. Yeah? Coming back to Coming back to, so Alok sir, she is my daughter and they are besties for the last 4 years.
Okay, hi.
That's why I have to keep reminding them that this is a class where it's only teacher and student, no friends. I mean, you can be friends to borrow ideas,
Right.
not for getting distracted. Now coming back to this one, if I say 5 to the power 3 by 4 into 5 to the power 1 by 4, how much that would be? Without calculator, yep. 5.
Yeah,
Five.
call.
Okay. 5. Everybody, Sohina 5. How much that would be? 5 to the power 3 by 4 into 5 to the power 1 by 4. How much that would be?
I'm like what form?
One more time.
I'm like what form?
Whichever form, you tell me one answer and then we'll see how close or far that is. Advik and Arav. What's looking up? Yes, Sanjita, go ahead. 5. Again. I asked Arav what is looking up and he just gave me an emoji with tears falling off. What does it mean? Sanjay and Salim, tell me what that is. 5. Nehan, 5.
Yep.
Okay. Dikshita, 5. Okay. So, this is simple. This is not troublesome, okay? Now, look at this. Simple thing. I have two exponents with different powers. And what I was saying in the beginning was, whether it's a natural number, rational number, negative numbers, we don't really care about it because here, when you are putting this rule, a generic rule, we did not put a caveat saying, oh, this has to be a natural number or a fraction or decimal or something very specific, right? We said that this is a rule. So that means that applies for this also. There is no differentiation between the type of number that you want to deal with. This rule is so very generic in nature. So for all the kids who are scrambling to figure out what it means, these are two exponents and we are talking about multiplying them using the first rule, and hence my powers will get added, which is 3/4 plus 1/4. 3/4 plus 1/4 is 4/4, which is 1. So that became 5 to the power 1, which is 5. Now you want to write that in exponent form, write 5 to the power 1. If you want to write that as a natural number, you just write 1. Both are same. Everybody okay? Yeah? Now, one problem is not good enough. Let's look at y5. There are other numbers in the world as well. Enjoy. Do it. And the only clue is we have no bias with any type of number or power. As long as you guys are not complicating it, it will be an easy peasy one. So take out all those complex thoughts out of your mind and then solve it. Yes, madam.
She stole my pencil.
That problem I cannot solve. I can just give you another one.
I gave you my pencil.
Don't waste your energy fighting it out. There's an easier solution. Solve it quickly. Everybody.
I'm going to use pencil because I know.
Take it. Don't waste your time. Do it.
Please use pencil.
All these household problems you can solve later. Solve this problem first. Okay. I'm assuming everybody is able to give it a try. Sandy, Sulin, Nihan, Sami, Azmi, Karav, everybody, right? Okay. Vasundhara, are you will try it? Okay, go for it. I'm giving you guys next 2-3 minutes so that I can take a quick nap and then wake me up once you guys are done.
Okay, I'll take off too. I think once you're done at 6, right?
Yeah.
Okay.
Gotcha.
Then I'll take.
Thank you.
Thank you very much. This is what I was going to
I'll close the doors, okay?
Thank you.
Yeah. बदमाशी बाद में पहले काम फटाफट. Do you understand what I said? I said don't be naughty in the class. Finish your problem first. That's what I said. Okay. No, see again, just think about it. It's not that big a deal. Milona, are you with Pravita? Okay. Sami, Nihan, everybody?
I don't really understand how to do it. I was just gonna wait until you explain it.
Okay.
Figure it out as we
Okay. Sami, while you are waiting for me to do it, my only clue to everybody in the class is keep one thing in mind that this teacher never teaches anything complicated. Try doing that in a simple way and see if you are able to decode it. Otherwise, I'm there, don't worry. Yes, Vasundhara.
I got 1/7 to the power 1/6.
Yeah.
I got 7.
You got 7?
Yeah.
We'll see. So whatever you got, review it so that you can figure out if that is correct or you missed something in between. Yes, Dikshita.
I got 1/7 plus 6.
1/7 to the power 1/6. Is that what you're saying?
Yes.
Okay. How about Samhita?
Wait, I want to use
Without the negative, I got 1/7 to the power of 1/6.
Okay. Yes.
I'm changing my answer to 7. No, I'm not. I'm just doing 6 divided by 20. I'm changing my answer to 7 to 1/7 to the power 1/6.
Okay.
She's cheating. No, I'm not.
This calculator is of no use, trust me. Because this problem only needs concept. Calculator is not equipped to give that concept. Ifsha, are you able to try it?
Yeah.
Okay.
Seven to the power. I got 1/7 to the power 1/3.
Okay. Yes, sorry, Ifsha, you completed it.
No, I made what does that change? That means I can use decimals, and you don't.
Okay. It's okay with that. I'll anyways simplify it. Yes, Nihan, what did you get?
I
But,
got 1/7 and 1/6.
okay. So, I'm giving 30 more seconds to all the kids, okay? So, Ifsha, when you are stuck here, right? Just think with a fresh perspective, okay? Try doing it from beginning and see where you miss something, okay? Anybody who's close to giving the answer, Sergeant Sulaim? Hiranya joined a little late, seems. Just now. A little while ago. Milana? I see Asita also. Asita came from nowhere. Where were you? Okay. So who's giving the answer now? Alright. So here's the deal. For the kids who came a little late, just to let you guys know that we had talked about exponents at length in the previous classes. In today's class, we are talking about rational exponents and negative exponents. Negative exponents we have done in the previous class also. We'll look at it one more time. What I have told the kids so far is, these are the 3 rules of exponent that we have learned in the past. X to the power a times x to the power b, where x could be any number, the power gets added. When you are multiplying exponents in the same way, the power gets added. When you are dividing, the power gets subtracted. And when you have exponents in a parenthesis and then you have power outside, you end up multiplying the power. These are 3 basic rules that we can apply to every type of exponent. When we are talking about rational exponents, this is a scenario that we are talking about, where you have a number, an exponent. When you have an exponent here, where the power is in the form of a rational number or a fraction, this is called rational exponent. So here, the situation was this. We had, everybody clear with the question, right? Ashrita and Hilanya. You guys are clear with the question? Somebody has to say once yes. Okay. Milana, you are clear with the? Milana, agree with me?
Yes.
Oh, she said yes. No, I was saying Milana, agree with me? Milana saying yes. What did I do? Okay. Alright, no worries. So coming back to this one. Sometimes you guys have to deal with my dad jokes, okay? You guys don't have a choice. So look at the numbers. I'm just wiping off the formulas to create some real estate here, which we'll use for solving this problem. So our question is 7 to the power 5 over 6 in parentheses power 1 by 5 divided by 7 to the power 1 by 3. While I did my best to make this question look scary to you guys, but actually it's not a scary question. And that is where my theory that everybody in the class is tired of, except Ifsha, is, I call it ran. If you want to stitch a story around it, it says who wins the medal in a race depends on who ran the best. Okay. Now what this stands for? R stands for read, A stands for analyze, and N stands for, are you wearing Nike shoe? No. Okay. Nobody is wearing Nike shoe here. N stands for Nike. And Nike's punchline is just do it. So what it means is, when you have a problem to solve, read it first, think about it, how you will approach it, and then you do it. Okay? That's a simple message. Though I try doing a lot of marketing around it, but the idea is simple. Have a problem, read it a couple of times, stare it so that you are trying to kill the problem. Try getting all the information from it, and then say, okay, fine, this is a rational exponent. I am trying to multiply here first, use the third rule, and then I will divide because my base are the same. You have made your mind right now. Okay, I'm going to use exponent rule, and then you jump onto it. Because when you put the thoughts, right, the way you're going to approach, if you are clear about it, your chances of being wrong is very, very less. Okay? So, Sammy, I know this is probably 50th or 60th time you are hearing this rant story from me. Sorry about that. But then, message the same. And why I do this on purpose is because I want to inject this approach in your brain that don't consider or evaluate a problem to be an easy or difficult problem without doing enough post-mortem of the problem. By reading the question again and again, you actually need post-mortem of it. You are breaking it into pieces. Oh, this one, this is my third rule of exponent, which says x to the power a in parentheses to the power b is equal to x to the power a times b. This is x, this is a, this is b. Let's find out what is the. So I am starting with my story now. So Ifsha, you can look at what everybody, not Ifsha only. Everybody in the class, look at how my story starts from here. Whatever I have. Okay, this part I will touch later. This is my third rule of exponent, which says something to the power something in parentheses to the power something else becomes something to the power this into this. So this becomes something to the power 5 over 6 into 1 over 5. Yeah? Sammy, with me?
Yes, sir.
Now, this part we got. Here we can do tic-tac-toe. See, tic-tac-toe is going to become a part of life for us. Yeah? Here you multiply the power because it was in parentheses. Right? So 5 over 6 times 1 over 5. And you got the 5s knocked out. So you're left with 7 to the power 1 by 6. So 7 to the power 1 by 6 divided by 7 to the power 1 by 3. This is nothing but 7 to the power. Now comes the second rule. X to the power a divided by x to the power b equals x to the power a minus b. So this becomes 7 to the power 1 by 6 minus 1 by 3. Yeah? Which is equal to 7 to the power 1 by 6 minus 1 by 3. You can say 3 into 2 and you multiply 2 here. It becomes 1 by 6 minus 2 by 6. So it becomes minus 1 by 6. Okay? This is the answer. And you can make this as 1 over 7 to the power 1 by 6. This is what we learned in the previous class. When you have a negative exponent, you can make it travel from first floor to second floor or second floor to first floor, and you can reverse the power from positive to negative or negative to positive. If you're thinking, what is going on? Yeah? I'll be good because I taught that in the last class, so I'll do it for you. And I know many of the kids in the class, they also must be thinking how this minus 1 by 6 became 1 by 6 positive. Yeah? So that is the underlying concept behind negative exponents. But let's first come to this point. Okay, we'll come to this part later. Look at the whole journey. We had something as an exponent in the parentheses and we had a power outside. To break this bracket, we use the third rule of exponent, which is multiply these two powers. And when you do that, you got 1 by 6 and then you have this. So now you have come to a point where you have something to power this divided by something to power this. It's a division case where you will subtract the power. Is it making sense, Sabi? Yeah?
Yes, sir.
Advik, Arav, Sohina, everybody with me? Or it's only me with me? Everybody with me? Arya, Ipsa, okay? This is making sense, right? So far this is making sense up to here?
Yeah.
Yeah? Just look at the story, okay? I mean, I'll take while, okay? This becomes this. You did tic-tac-toe. You came to this point where you can divide this exponent by this exponent. That's it. And then when you divide, when you have the same base, you subtract the power. Power of the denominator gets subtracted from the power of numerator. So 1 by 6 minus 1 by 3, that's what gives you minus 1 by 6. So far is that okay? Everybody okay? Are they okay? Sandy?
Yeah.
Okay. Now, time for some music and dance. And Maida knows how much dancing skills I've got. Yeah? So we will not, I will not dance, I'll make the numbers dance. That's what I meant by that. I have, what happened to Advik and Arav? Very quiet today. Cry. Nobody spill milk. Alright. So now let's do some music and dance. That's what I was saying. So there is no music, it will be a silent dance. If I have 5 to the power 1 or 5 to the power 2, everybody is clear, right? 5 to the power 2 is 5 into 5. Yeah? It's a clear.
Yes, sir.
Sohina, Sammy, Gayatri, everybody okay?
Yes, sir.
Okay. If I change the plan a little bit and say 5 to the power minus 2, what does it mean? Say that again. Say it loud. It's okay.
It's negative 25.
Negative.
25.
Negative 25.
It's 1 over 25.
1 over 25. Sohina.
It's negative 12, negative 0, 2, and then if you approach it like 1, represents the negative symbol, and like second part of the subtraction direction. I mean, like the negative represents 1 and like 3 steps. It will be 1 at the top, and then 3 steps like positive.
Okay.
Positive.
So what did we? Asita. I'm hearing something that I'm not supposed to hear. Okay. Vasundhara. What did you get? I mean,
Oh, you want to be something?
you have to tell me. I mean, you have to basically teach me. How do I read this thing? Yeah.
When it's like a negative exponent, you can like just turn it into 1 over 5 over x power 2.
Wonderful. Adri,
I got 1.
you got 1. 5 to the power minus 2 is 1.
Oh wait, I don't know. Never mind. I got 1 over 5.
Why not?
She
Here.
lost her water bottle.
Sorry.
She's looking for it.
Here. Arif, what do you get? Okay. Nihal, how do I read this? 5 to the power minus 2, what does it mean to me?
So if it's a negative exponent, you just make it to a 1, like you go 1 over 5 to 2 to the power 2.
Okay. Vasundhara, you're saying something? Yeah.
I think
Okay. So here's the thing. So Ipsa, you heard many options from the kids. Which one you are leaning towards? Some of the kids said, okay, let's forget about this. 5 to the power minus 2 is what we are trying to find out. Correct? So some of the kids said, okay, it will be equal to minus 25. Some of the kids said it will be equal to 1 by 25. There are 2 options we got. So which one you are leaning towards? It's okay.
Negative 25.
Negative 25? Okay. Now, I will not assume anything. I will go with the thing that we know about. Okay? So this is the number I have. 5 to the power minus 2. Now, let me put the rules here again. X to the power A divided by x to the power B equals x to the power A minus B. You guys agree? You agree, right? Everybody? So, Ara, Sammy, everybody with me? Or I can write this in a different way. I will write this guy first. X to the power A minus B equals x to the power A divided by x to the power B. Is that okay? It's here. Can I rewrite this formula this way? Meaning this guy first and this guy later? That's okay? Okay. Now come to this one. 5 to the power minus 2. Is it okay for me to write this as 5 to the power 0 minus 2?
Yeah.
Yeah? That is what I will play with. So 5 to the power 0 minus 2. Now compare this with this formula. You have something to power, something minus something. I can rewrite this as 5 to the power 0 divided by 5 to the power 2. That is how it is coming to this point. Anything to the power 0 is how much?
1.
1. Look at the whole transformation that you saw. 5 to the power minus 2 with all the gymnastics, circus, drama, it came here. And the sign changed to from minus to plus. Okay? So if you ever had, so Adya here beta. If you have any number, yes beta.
Wouldn't the 1 over 5 to the power 2 still be 1 over 25?
Yeah, 1 over 25. So this is see. The basics will not change for us. 1 over 5 to the power 2 means 1 over 5 into 5. Yep. Santa has to wait for 2 more weeks. So here, coming back here, first serious thing. Whatever number I have as with a negative exponent, that can be moved from numerator to denominator and the sign changes. If somebody says 6 to the power minus 2 by 5, you are okay to just move it down and change the power from negative to positive. If you ever had 6 to the power, let's say 1, you can also write this as 1 over 6 to the power minus 1. Same thing. So that's the dance and song I was talking about. Silent song, no singing, only dancing of the numbers. When you have a negative power, you can move it down, it becomes positive. If you have positive power, you move it down, it becomes negative. Or vice versa. If you have something in the denominator, if you move this guy up, this will become negative. Yeah? Now, I will give you guys one problem to solve, and I promise for next 1 month I will not, or maybe 2 months, I will not come back to exponents. We have muddled the water enough. Those Sandin, Suleen, Dikshitas, Sanjita have not been talking about it, but I know many of you are already tired of exponents, right Dikshita? See, I'm reading your faces also to see who's getting tired of the concepts. See, I'm not saying that once we learn something, we'll not come back to it, we'll come to it. Because that's how we revise and the concept becomes ours. But then, we have other things to learn as well. So we'll move on from exponent. Provided, when I give the assignment to you guys, everybody watches the video of the class and submits the assignment before next class. Next class is not the class tomorrow, I'm saying before next week. So everybody has to do the assignment and send me the assignment so that I get the confidence that okay, all my kids have understood the concept. So now I want you guys to solve this problem. Okay, yes, sir.
Like first number is 7 or 1?
So I'll read it for you guys. 10 to the power minus 2 into 5 to the power 4 into 7 to the power minus 3 divided by 7 to the power half into 5 to the power 3 by 6. And treat this problem as an opportunity to play. Don't get stressed out that this is a monstrous problem. It's not a monstrous problem. You guys have to play with math, okay? And I promise I'll not bother you guys for next 3-4 minutes at least. I'm putting a sellotape here. Deal with it. is trying, right? Try and let it go down, but try for sure, okay? Everybody, Shannon, Celine, Nihan, Sami, Dikshita, Hiranya, Milana, Ashrita. You can Arav as well. Gayatri also. Everybody, okay? Gayatri, are you able to try it out? When kids don't talk, I get a little worried, okay? That's why I'm calling out names, just to make sure that everybody is at least able to give it a try. Mr. Emoji. You have to see, I am assuming that you are not a bot, neither am I. So we can use unmute the button, tell me whatever you want to tell. Alright, that is for you. Today, when you are in the class, I have to keep on stopping you that okay, we'll talk only things which are relevant. When you are not in the class, you are not even talking.
Sir, you
Yes.
have to simplify the question, right?
Yeah, simplify it and tell me after doing all that you want to do with this, what is the final thing that you are coming to? Be it in a simple form or be it in the exponent form, I'll leave it to you guys. At least that will give me a clue how far you could go with all the concepts that we know. If sir, is it bothering you then?
No.
No? Okay. No, it should not. It's an opportunity to play, trust me. Myra, what's happening? Almost? Okay. Ashrita, the laptop is glitching. Okay, sure. Yes, Anvita. What did you get?
Do we have to use like square roots or can we just leave it?
Leave it to the simplest point that you can leave.
Okay, so I got 5 to the power of 7 over 2
Okay?
over 100 times 7 to the power of 5 over 2.
Okay. Let's see what everybody else is getting. Yes, Dikshita.
I got 1 over 7 to the power of 5 over 2, 10 to the power of 2, and 5 to the power of 7 over 2.
Okay. Yes, Dikshita.
It was by mistake, sir.
Okay, that's fine. And Dikshita, I forgot your sister's name. One more time, please.
It's Dishali.
Dishali. That's what. She joined the Algebra 2 class. I talked to her and then I was wondering. Dikshita, Dishali. Okay, fine. So I do very bad with names, right? That's why I'm trying to minimize on those mistakes. Okay. Yes, Vasundhara.
I got 5 to the power 7 over 2 divided by 10 to the power 2
Hmm.
times 7 to the power 5 over 2.
Okay. Yes, yes, sir. Tell me that. Now, what is it, Myra? Are you
I'm still solving it.
still solving it? Okay. So here's the thing. So we have only 6 more minutes. So time for what or how much your teacher can do. Let's see if your teacher is even qualified to be able to solve this or not. Let's see. So let me write it in the corner so that I can create some space for myself. What happened, Advik? No answers today? Is it too much below standard or something that you're tired of now?
I'm tired.
Tired? Oh my god. Tired of exponents, or you're tired of some other reason? Okay. Alright. So let's come to this one. So whatever we have here, we will go with a simple story. So let's do it step by step. 10 to the power minus 2, okay, into 5 to the power 4, into 7 to the power minus 3. Why am I rewriting the whole thing? No point, right? So let's do one thing. First thing first, all the negative powers, they unnecessarily bother, right? Why 2? I mean, 5 to the power 4, 5 to 5 to 5 to 5 into 5, I mean 4 times. This is getting confusing. So whenever you have a negative number, first you get rid of the negative power. Meaning you will move this guy below and this becomes positive. Feels better. This guy is done. Then you have 5 to the power 4, write it as is. 7 to the power again negative. Negative is you bring it down and becomes positive power. So this is done. Now come to this number here. Again negative power, make this guy go up. It becomes positive power. Then you have 5 to the power 3 over 6.
So
Okay.
can you repeat that step?
No, so what I'm saying is, whatever we had here, all the positive numbers, positive powers, easy to understand, right? I mean relate. 5 to the power 4, 5 to 5 into 5 into 5, 4 times. 10 to the power 2, 10 into 2, 10 into 10, 2 times. But when you see a negative power, that raises an unnecessary red flag, right? I mean, how do I deal with it? So the first thing we'll do is get rid of all the negative powers. So wherever we had negative powers, we move them. So here on the numerator, we had this one and this one is negative power. We moved both of them to the denominator. So the power changed from negative to positive. Okay? So these two numbers moved down and this one was positive, so remained in the same place. Then we came to the denominator also. Here also we have one negative. We moved this guy upstairs and became positive. And the other guy was positive, so we left it here. Okay. Now, at least visually this looks better, right? Every power is positive, some fractions also, but we'll see. Now, let's see if we want to solve something. 5 to the power 4, 7 to the power 1 by 2, this 10 to the power 2. Okay, 10 to the power 2 is nothing but 10 I can write as 5 into 2, right? This is 10. Is this okay? Then I have 7 to the power 3. Let it be. Then I have 5 to the power 3 by 6. Now, let's look at it. 5 to the power 4. Now let's do one thing. Let's bring all the similar numbers together. 7 to the power 1 by 2 and 7 to the power 3. This can be solved together. So we will say this becomes 5 to the power 4. We will get this. So here it becomes 7 to the power 1 by 2 minus 3. Yeah, this one, division. Second rule, something to power something divided by something power something else, subtract it. So these two are together now. Here, this is 5 to the power 2 into 2 to the power 2 when we break this bracket open. And this is 5 to the power 3 by 6. Here, now all the 5s together. So it becomes 5 to the power 4 minus 2 from here minus 3 by 6. This is the 5 thing, okay? This one, and this one together. And then you have a 7, which is 7 to the power half minus 3, which is minus 5 by 2. And you can do this calculation. 3 minus half is 2.5, which is 5 by 2, right? So, divide by 2 to the power 2. So, 5 to the power 4 minus 2 is 2, and 2 minus 3 by 6. 2 minus 3 by 6 will be nothing but 12, 6 and 6 here. So, this becomes 12 by 6 minus 3 by 6, which is 9 by 6. So, this became 5 to the power 2 minus 3 by 6, which is 9 by 6, divided by 2 to the power 2 into 7 to the power minus 5 by 2. This is where you will probably leave it. Or 9 by 6 is nothing but 3 by 2. So 5 to the power 3 by 2 divided by 2 to the power 2 into 7 to the power 5 by 2. You moved it again down so that this becomes positive. In this whole thing, right? I mean, was there anything literally for me to teach? No. We just applied. Wasn't there, you're saying something better? Okay. So basically, in the whole thing, there are only two concepts that we applied. One is when you have negative powers, move from numerator to denominator to change it to positive, and then whatever you have, find out different ways to combine the matching numbers or like terms, and then apply the rule of exponents. And there are three rules of exponents. When you multiply two exponents with the same base, the power gets added. When you divide one exponent by another exponent with the same base, the power gets subtracted. And when you have an exponent in parentheses, and outside you have a power, the power gets multiplied. These are three rules that will apply for regular exponents, negative exponents, as well as rational exponents. Yes? Yeah. So, net, these are the concepts that we have to learn for exponents, and I promise we'll take a break from exponents for some time before anybody gets further tired of it. Yeah. Is everybody clear about what we did? If you hear the term rational exponents, it should not bother you. It's same thing exponents, just that you're dealing with power which is in the form of rational number. But the underlying rule remains the same. Yeah? Alright? With that being said, I'll let you guys go. We'll pick up some other topic tomorrow and we'll break our head with that. Alright? Bye bye. Have fun.